What do the bots say?
This is madness.
Bite my shiny metal ass.
I'm an android.
My name is Optimus Prime.
What do the bots say?
Hello, everybody. How you doing? This is Steve Favis. This is the Mr. Robots podcast. Thank you for watching. I have some commentary today. I'm going to play some news, and Elon Musk announced a few months ago that he's entering into the humanoid robot market. And for those of you who know about me, I have some advanced patents in humanoids, and there's some patent grants in 2018. So I'll cover some news first that's going on as far as some technology news anyway. And I'll share some on my screen here. Hopefully it works when I flip it over.
Now, unlike Dojo, obviously that was not real. So Dojo is real. The Teslabot will be real. But basically, if you think about what we're doing right now with the cars, Tesla is arguably the world's biggest robotics company because our cars are like semi-sentient robots on wheels. And with the full self-driving computer, essentially the inference engine on the car, which will keep evolving, obviously, and Dojo, and all the neural nets recognizing the world, understanding how to navigate through the world, it kind of makes sense to put that onto a humanoid form. And we're also quite good at sensors and batteries and actuators. So we think we'll probably have a prototype sometime next year that that basically looks like this. And it's intended to be friendly, of course, and navigate through a world built for humans and eliminate dangerous, repetitive, and boring tasks. We're setting it such that it is, at a mechanical level, at a physical level, you can run away from it. And most likely overpower it. So hopefully that doesn't ever happen, but you never know. So it'll be a light, yeah, anyway, 5 miles an hour. If you can run faster than that, it'll be fine. So yeah, it's around 5'8". Has sort of a screen where the head is for useful information, but it's otherwise basically got the autopilot system in it. So it's got cameras, got 8 cameras, and yeah. Full self-driving computer, and making use of all of the same tools that we use in the car. So, I mean, things that I think that are really hard about having a useful humanoid robot cannot navigate through the world without being explicitly trained. I mean, without explicit, like, line-by-line instructions. Can you talk to it and say, you know, please pick up that bolt and attach it to the car with that wrench, and it should be able to do that. It should be able to, please go to the store and get me the following groceries, that kind of thing. So, yeah, I think we can do that. And yeah, this I think will be quite profound, because if you say it like, what is the economy? It is at the foundation, it is labor. So, what happens when there is, no shortage of labor? This is why I think long term that there will need to be universal.
Can you hear me now?
Income. Yeah. But not right now, because this robot doesn't work. So we just need a minute. So yeah, but I think it's essentially in the future, physical work will be a choice. If you want to do it, you can, but you won't need to do it.
Looks like I have an audio issue.
And,
I'm going to pause this video here for a bit,
yeah, I think
and then I'm
obviously
going to
has
try
profound
fixing my
implications for you.
audio. Okay, cool. I think I've solved the the audio issue. Sorry about that. I'll go. I have this podcast recorded anyway, so I'll repost it. But just going through the actual video was pretty interesting. I'll be able to post this on my. I have the recording. It's being recorded also. Let me go ahead and fix this, and I'm gonna add a audio source here. Okay, let's go ahead and fix this here. I think I need to change the video camera here, window capture. I'm going to close this one right here. Okay, can you hear me now? How's that? Is that audio working okay? Okay, cool. Thanks. Thanks, Spidey. All right, let's continue playing this video. I'll scroll through this again a little bit. So Elon, he's I'm of course getting sunlight in my head from the studio now. That's awesome. I'll move over here to get away from that sunlight. Okay, let's see here. Let's go ahead and play Elon Musk video here. Let's see what's going on.
Economy, because given that the economy at its foundational level is labor, I mean, capital equipment is just distilled labor, then is there any actual limit to the economy? Maybe not. So, yeah. It's basically got the autopilot system in it, so it's got cameras.
I was just commenting on his the anatomy on his robot, basically. So it's great how the sunlight is just
full self-driving computer.
It's awesome.
And making use of all of the same tools that we use in the car. So, I mean, things
right,
that I think that are
the
really
computer
hard
looks
about,
fairly large. Looks like he's not doing any cloud.
Humanoid robot is
he's not doing any cloud
compute
externally, at least. It looks like it's happening in real time.
Explicit, like
so with these this size of boards, he basically should be able to do the real time calculations for conditions that are going to happen in a dynamic environment that a humanoid would be working in, basically. So looks like the simulation may happen on board, basically.
Can you talk to it and say, please pick up that bolt and attach it to the car with that wrench, and it should be able to do that. It should be able to, please go to the store and get me the following groceries, that kind of thing. So, yeah, I think we can do that. And yeah, this I think will be quite profound, because if you say it like, what is the economy? It is at the foundation, it is labor. So, what happens when there is,
Again, he's addressing the labor market again. This is the primary drive on why I'm developing the robots myself. Again, I don't want humans being treated like robots. I don't think anybody likes being treated like a robot. And the technology is here as far as the Lego blocks. They are ready to be built and assembled in a proper manner to make humanoids. We have enough compute power. We have enough simulation power. We have good enough AI models as of today. A lot of the AI academics are, I think, in my humble opinion, splitting hairs as far as deep learning and stuff like that. I think what we have is more than sufficient, almost on all open source, from Keras to Kappa or whatnot. So I think all these deep learning architectures are fine. They work great. They do what they're supposed to do, basically. So I don't think we really need any super further development as far as deep learning. Maybe hardware wise, we could get some stuff that's not stolen by crypto or crypto miners, basically, or inflating the prices of hardware for crypto mining and taking away gamer cards or whatnot. But for the most part, he's addressing the same issue I am. So see what else he plays here.
And, yeah, great. So we're happy to answer any questions you have about anything on the software, hardware side, where things are going, and yeah, fire away. We have, because the lights are like interrogation lights, we actually cannot see. There we go. Great. Oh, yeah. All right, cool.
I can just, okay, there we go. First off, I mean, thanks to all the presenters. That was just super cool to see everything. I'm just curious at a high level, and this is kind of a question for really anyone who wants to take it. To what extent?
You know what? I'm going to answer these questions as if it was my AGI, or my artificial intelligence and robot. Let's try this. Let's see what he's going to ask.
Are you interested in publishing or open sourcing anything that you do?
Negative. FarCorp will not be publishing or open sourcing the hardware or software. There's too much of an ethical issue behind this, basically. Which, again, I talk about this a lot in my podcast. We don't want robots being trained to do things that we don't want them to do, basically. And there is a ethical issue behind being able to train these things, and we want to have control over who trains these things and what they will be training them for. So let's see what he says about about open sourcing this stuff. He probably shouldn't. I doubt he will.
For the future?
Well, I mean, it is fundamentally extremely expensive to create the system, so somehow that has to be paid for. I'm not sure how to pay for it if it's fully open sourced. Yeah, unless people want to work for free.
Well, that's a good answer. But yeah, people do in the open source community work for free too, for labor of love, a lot of the stuff. But yeah, you didn't even address the ethical issues behind somebody controlling one of these things.
But I should say that this is, if other car companies want to license it and use it in their cars, that would be cool. This is not intended to be just limited to Tesla cars.
Is for the Dojo supercomputer. So did you solve the compiler problem of scaling to these many nodes, or if it is solved, is it only applicable to Dojo? Because I'm doing research in deep learning accelerators, and getting the correct scalability or the distribution, even in one chip, is extremely difficult from the research project's perspective. So I was just curious.
Excuse me, Mike.
I'm not really sure, it just seems like scalability, I still go back to the amount of data you're feeding these things. If you're talking about massive data sets, your data set's too complex if you're having trouble even on desktop hardware to build an AI model in a decent amount of time. So I think this is I don't know. Let's see how he answers this. At least that's applied to my technology anyway. Our data set's not too complex. The hardware of today is going to run it fine.
Bill, you want to?
Have we solved the problem? Not yet. Are we confident we will solve the problem? Yes. We have demonstrated networks on prototype hardware now. We have models, performance models showing the scaling. The difficulty is, as you said, how do we keep the localities? If we can do enough model parallel, enough data parallel to keep most of the things local, we just keep scaling.
This poor guy's really nervous.
We have to fit the parameters in our working set in our SRAM that we have, and we flow through the pipe. There's plenty of opportunities. Sorry, as we get further scale for further processor nodes, have more local memory trade-offs with bandwidth, we can do more things. But as we see it now, the applications that Tesla has, we see a clear path.
And our modularity story means we can have different ratios, different aspects created out of it. I mean, this is something that we chose for our applications internally.
Sure.
I was just saying that the locality portion of it, given that training is such a soft scaling application, even though you have all this compute and have a high bandwidth interconnect, it could not give you that performance because you are doing computations on limited memory at different locations. So I was that's very curious to me when you said it's solved, because I just jumped onto the opportunity and would love to know more, given that how much you can open source.
Right in there.
Yeah.
Yeah, I guess the proof's in the pudding. So we should have Dojo operational next year, and I think we'll obviously use it for training, video training. I mean, fundamentally, this is about like the primary application initially is we've got vast amounts of video, and how do we train vast amounts of video as efficiently as possible?
Looks like he's training RGB or pixel-based training. I don't think that's an optimal approach for this. He just said that they're training it with RGB cameras. That could be why they're concerned about the data issue. Yeah, they're feeding too much data. That could be dirty data, and not only that, you have to deal with lighting conditions, shadows, reflections. I wouldn't go that approach. That's not what we're doing internally here, basically. So that's going to be a huge challenge. That's I'm kind of cringing when I hear about that. He's already got a technical challenge. That engineer you just talked to knows what he's talking about.
And also shorten the amount of time. Like if you're trying to train to a task, like just in general, innovation is how many iterations and what is the average progress between each iteration. And so if you can reduce the time between iterations, the rate of improvement is much better. So if it takes like sometimes a couple days for a model to train versus a couple hours, that's a big deal. But the acid test here, and what I've told the Dojo team is like it's successful if the software team wants to turn off the GPU cluster. But if they want to keep the GPU cluster on, it's not successful. So.
Hi, right over here. Love the presentation. Thank you for getting us out here. Love everything, especially the simulation part of the presentation. I was wondering, it looked very, very, very realistic. Are there any plans to maybe expand simulation to other parts of the company?
I must be missing the simulation aspect. I didn't see that video. Let me see if I could find that. I'm curious what he's showing on that.
Yeah.
Looks like they're recruiting. Keep on going through this video. Let's see here. He's got a lot of challenges, and I don't think this is the optimal approach for what.
Right over here.
This isn't what I would
love
do.
the presentation. Thank you for getting us out here. Love the.
Yelling something at the car that the car needs to understand what that is.
GPT that Andre put out there.
Like emergency vehicles or.
And I want to ask that when you do the photometric process, multi-view geometry, how much of an error do you see? Is it like 1 millimeter?
Yeah, and then there's the prime directive is don't crash.
Right, and that's true for every country.
Yes, this is the prime directive. I mean, even right now, the car is pretty good at not crashing. And so just basically, whatever it is, don't hit it. Even if it's a UFO that crash landed on the highway, and still don't hit it. You should not need to recognize it in order to not hit it. So that's very important.
And I want to ask that When you do the photometric process, multi-view geometry, how much of an error do you see? Is it like 1 millimeter, 1 centimeter? So I'm just, if it's not confident.
Is the humanoid that's behind you guys, is that kind of brought out of the production hell timeline and saying that humans are underrated in that process?
Well, sometimes like something that I say is taken to too much of an extreme. There are parts of the Tesla system that are almost completely automated, and then there are some parts that are almost completely manual.
I'm going to skip through that question.
Drops by like.
And how do you plan to scale it? And how do you plan to scale it in multiple data centers?
Sort of the advanced cooling that we developed.
Skip that question too. I'm interested.
So as you could see, like Andre's models are not just for cars. Like there are auto labeling models. There are other models that are.
Users are still essentially running it neural net training in emulation mode. So with Dojo, we're saying like, okay, let's just ASIC the whole thing. Let's just have this thing it's built for one purpose, and that is
okay,
neural
this
net.
is interesting. I want to hear this section.
But it's very much optimized to be a neural net. So CPUs and GPUs, they're not made to be. They're not designed specifically for training neural nets. We've been able to make GPUs especially very efficient for training neural nets, but that was never their design intent. So it's basically GPUs are still essentially running it neural net training in emulation mode. So with Dojo, we're saying like, okay, let's just ASIC the whole thing. Let's just have this thing it's built for one purpose, and that is neural net training.
It's
it's
a pretty bold
any
move.
system that is designed
I'm going to say
specific.
that's pretty risky. Basically, what an ASIC is application-specific integrated circuit, and what he's saying is he's going to lay the copper out to handle those neural nets. He doesn't mention anything about FPGAs or field programmable gateway arrays. I'm surprised he's going ASIC. That's a very, very I'd say it's kind of a risky move. Once you build those things, you're kind of committed on that logic, assuming the logic is perfect to begin with, or what you wanted. I'm surprised he's not talking about FPGA or whatnot, or field programmable. That's why they call it field programmable, because you literally change the copper logic on the board, so you're not kind of fixed in with an ASIC. ASICs are extremely fast. ASICs are used for crypto mining, very customized crypto mining hardware. But the point or the problem is that it will only do that task. Basically, it's a kind of a pre-Turing machine methodology where it's one program to one piece of hardware, basically. So the Turing machine kind of opened that up and made a universally programmable computer, basically, which could do one computer for all sorts of different computing tasks, basically. So ASICs are extremely fast. But once you're committed to that hardware, the design changes are going to be extraordinarily high, especially if you have a high production run, or if you need to upgrade your boards, or you probably will need to upgrade your boards. So it's just a matter of time if he commits to using ASICs to having those ASICs in there. I mean, you think about all the software updates that happen and changes that happen on even hardware on just cars themselves. It's never right the first time, so it's pretty risky, but we'll see what else he has to say here. It'll be fast but risky, and if you get it right the first time, then it's perfect, but it'll be pretty hard to do that.
Purpose will be better than one that is designed for a general purpose.
Yeah, I had a question here. Hi. So you described two separate systems. One was for vision, other was for planner and control. Does Dojo allow you to train networks that cross that boundary? And second thing is, if you were able to train such networks, would you have the onboard compute capability in the FSD system to be able to run that under your tight latency constraints? Thanks.
Yeah, I think we should be able to train planner networks on Dojo or any GPUs. It's really invariant to the platform. And I think, if anything, once we make this entire thing end-to-end, it will be more efficient than decoding a lot of these intermediate states. So you should be able to run faster if you make the entire thing end-to-end neural networks. We can
and eventually fine-tuning end-to-end. So I think that's definitely where this is headed.
Yeah. And the discovery really is like, what are the right architectures that we need to place in the network blocks to make it amenable to that task. So like Andre described, we can place spatial RNNs to help with the perception problem. And now it's just neural network. So similarly for planning, we need to bake in search and optimization into the network architecture. And once we do that, it should be able to do planning very quickly.
It doesn't say anything about autonomously scanning the environment, and that'll be difficult converting. I want to say, I'm not sure if I should talk about this yet. This is still getting close to what I do and some of the trade secrets. But the problem with an RGB camera and with an RGB camera is you're not going to be able to learn environmental physics as easily. I won't talk about this too much. This is getting into proprietary stuff for my corporation, but the problem with an RGB camera, and part of my definition of artificial general intelligence is you're going to have to at some point manipulate the environment, which they're going to do here. The problem is if you go with an RGB camera, that the collisions, the physics, eventually there's going to have to be some sort of simulation element. When you start talking about simulation, you're starting to tread on my patent territory. My patent is published and it is granted in 2018, and there's a simulation aspect, and not only that, the robot is aesthetically at least 80% of what Tesla's doing for the most part. But when you start adding the simulation aspect and the form factor, you're getting close to the patent that was granted me in 2018. So it's going to be challenging avoiding the logic that I have down there, along with the form, along with the simulation element. So I'm not sure how he's going to do that. Having an onboard computer, I don't think is the optimal solution. I think that's power hungry. That board looks like it'll chew up a 24-volt diesel battery in a few hours, basically. So I could already tell when you're starting to run ASICs and a board that size, it's going to be challenging doing the heavy compute on site or on board locally, basically. So my patent is covering a cloud-based system that kind of gets the data from the edge board, and then the model is pushed to it, basically. So this is all published in the patent. So he's going to have some challenges here. I see risk in using ASICs. I see risk in doing the real-time compute. And not only that, but I see extraordinary power risks having the onboard system onboard. It looks like it's all onboard, and there's no cloud system, basically, or a separate imagination or consciousness or whatever you call it, just for an analogy, basically. So the robot is still local, very, very heavy local on that. So I'm a bit skeptical about this happening in a year. Actually, I'm very skeptical of this happening in a year, and its team hasn't seemed to address the offloading a lot of the compute off and just pushing the model to the actual system. So that, again, it's hard getting through my patent without that stuff. So I'm curious to see if he actually has a provisional patent, or if he'll ever publish it or release it, basically. So I'm really curious to see that. But for the most part, this isn't the optimal humanoid robotic system, basically. So
similar to C++ algorithms.
Okay. I think I had a question very similar to what he was asking about. It seems like a lot of neural nets are around computer vision, and kind of traditional planning, you had model predictive control and solving convex optimization problems very quickly. And I'd wonder if there's a compute architecture that's more suited for convex optimization or the model predictive control solutions very quickly.
Yeah, 100%. We want to bake in, like I said earlier, we want to bake in these architectures that do, say, model predictive control, but it just like replace some of the.
I don't really care about that question.
In fact, I'm sure you can get to much safer than human with control and planning, primarily in C++ with perception, vision in neural nets.
Hi. My question is, we've seen other companies, for example, use reinforcement learning and machine learning to optimize power consumption in data centers and all kinds of other internal processes. My question is, is Tesla using machine learning within its manufacturing design or other engineering processes?
No.
I discourage use of machine learning because it's really difficult. Unless you have to use machine learning, don't do it. It's usually a red flag when somebody says, we want to use machine learning to solve this task. I'm like, that sounds like bullshit. 99.9% of the time, you do not need it. So.
I agree with that. That's
yeah, so we're doing, at the bottom of the stack, it's just traditional game techniques, just rasterization, real time.
Specifically
okay,
for
here's
neural.
a question here. Good question.
Hi. Based on your videos from the simulator, it looked like a combination of graphical and neural approaches. I'm curious what the set of underlying techniques that are used for your simulator and specifically for neural rendering, if you can share.
Yeah, so we're doing, at the bottom of the stack, it's just traditional game techniques, just rasterization, real time, very similar to what you'd see in like GTA. On top of that, we're doing real-time ray tracing, and then those results were really hot off the press. We had that little asterisk at the bottom that was from last night. We're going into the neural rendering space. We're trying out a bunch of different things. We want to get to the point where the neural rendering is the cherry on the top that pushes it to the point where the models will never be able to overfit on our simulator. Currently, we're doing things similar to photorealism enhancement. There's a recent paper enhancing photorealism enhancement, but we can do a lot more than what they could do in that paper because we have way more labeled data, way more compute, and also we have a lot more control over our environments. And we also have a lot of people who can help us make this run at real time. But we're going to try whatever we can do to get to the point where we can train everything just with the simulator if we had to, but we will never have to because we have so much real-world data that no one else has. It's just to fill.
How are you getting the data into the simulator, though? That's the tricky part. The only way you could really do that is by getting the robot to literally play around with the environment like a child or a baby would with his environment. So even though you have that real world data, how are you going to get that in the simulator, and how accurate is it going to be, basically? So it's another issue that at least I see.
Filling the little gaps in the real world.
Yeah, the simulator is very helpful when there's these rare cases like collision avoidance right before an accident. And then, ironically, the better our cars become at avoiding accidents, the fewer accidents there are, so then our training set is small, so then we have to make them crash in the simulation. So it's like, okay, minimize potential injury to pedestrians and people in the car. You have 5 meters, you're traveling at 20 meters per second.
Your pipeline?
So currently, we're producing the videos straight out of the simulator, the full clips with kinematics and everything, and then we're just immediately training on them, but it's not the entire data set. It's just a small targeted segment, and we only are evaluating based on real-world video. We're paying a lot of attention to make sure we...
I need to look up this video to see the Teslabot.
Predict what this road will look like.
Let me see if I can find Teslabot simulator.
When it's out of sight, like it's around the bend, and it predicts the road with very high accuracy.
Let's see if I must have missed this video. I don't think I'm going to be able to find the video. That's my commentary for this. I'm not really seeing him. I see some huge challenges that he's going to have, in my humble opinion, anyway. So, I wish I could see that simulation video. It must have been, that was a CNET video that I was reviewing. I wish there was some way I could actually see the simulation and see what they're doing, basically. But for the most part, I still think it's, I think he's got a huge challenge of having that large of a computer and how many resources it's going to take as far as energy and power. And I'm not really sure why he's using an ASIC. At least at this phase anyway. I could see it, maybe 15, 20 years from now. It just seems very risky committing this much stuff onto an ASIC. So anyways, well, I think this concludes the broadcast for today. Thank you for viewing. If you viewed this later on, I'll probably try to broadcast every day at 3 p.m. with news and updates. Next time I'll get my audio working properly. So sorry about that. I'll repost this podcast on Mr. Robot's podcast, basically on iTunes, Spotify, pretty much all the podcasting areas. So thanks a lot for viewing, and here we go. Here's my outro.
Servos go, lights go.
Welcome to the Mr. Robots podcast, a show about